Good morning, friend. In last lecture, we have completed chapter number 4. So total, we have completed 1 to 5 chapter that we have completed. 1 to 5 we have completed. 7 we have completed. 14 we have completed. 15 we have completed. Now we want to start chapter number 10, that is circle. So overall 5, 6, 7 and 8, and this is 9th chapter we have started. Chapter number 10 we have started now. So in chapter number 10 it has only 4 or 5 marks weightage. Now weightage may be changed because of the syllabus is reduced. So in chapter 10, first of all, we know the basic concept. We go through the basic concept. So in basic concept, what we have to concentrate, first of all, go to the 9th standard. And in 9th standard, we know the definition of circle. So first of all, we have know the definition of circle. So what is the definition of a circle? A circle is a collection of all the points in a plane. A circle is a collection of all points in a plane which are at constant distance from a fixed point. Constant distance we can say radius, and fixed point we can say center. Now if you will see, there is a one circle. Here if we will draw a one circle, so here it is a center, we can say O. So definition means a circle is a collection of all points in a plane which are at constant distance. So this is our constant distance. Here we can say radius. Every time it is same. Every time we can say distance is same every time. And O is called center. So that is a definition of circle. You have also studied various terms related to the circle like chord. Now definition of chord, we know that the whose endpoints end on a circle. Whose endpoints end on a circle. So we can say here it is, now we go properly. If I will draw one tangent, that is A and B. Now it is a chord, it is a definition of chord. So chord whose endpoints at the circle, whose endpoints are on the circle, we can say chord. Segment, sector, already we have to discuss this in the chapter number 12. Here we have to discuss about its intersecting lines. So now let us examine the different situation that can arise when a circle and a line. In this chapter we are discussing about the circle and line. Chord, segment and sector we are discussing in that chapter number 12. It is also related area of circle. So now if you will see, 3 situations are there, first, second and third. In it you will see that in first figure, line which is not intersect. Line is not intersect. Here line is intersect into 2 points. Here line is touch the circle at a 1 point. So when line touch the circle at a 1 point, we can say tangent. When line intersect the circle, we can say secant. Here we can say non-intersecting line. Non-intersecting line. Here line is not intersect. So we can say non-intersecting lines. So in first condition, PQ is non-intersecting line. In second condition, it will be intersect the line segment, a line intersect the circle into 2 points, that is A and B. And here in third condition, line PQ touch the circle at a 1 point. So 3 conditions and 3 definitions we must understand. So in figure 10.1, the line PQ and the circle have no common point. So here no common point. Here if you will see with in figure 10.1 there are two common points A and B that the line PQ and the circle have. So here are two common points. Common points. In this case, we call PQ as a secant of a circle. So in first condition, no common point is there. We can say non-intersecting line. In second condition, two common points, we can say secant of the circle. And in third condition, only one point A, which is the common to the line PQ and the circle, it is called tangent to the circle. So you must know, or you must understand properly what is the meaning of secant, what is the meaning of tangent. Secant का मतलब क्या है और tangent का मतलब क्या है. Secant का मतलब है जब line intersect the circle into 2 points, it is called secant. When line touch the circle into 1 point, we can say tangent. So in this lecture we have to go related with the circle and line and tangent. So we go for deep how tangent is now made. So we go for tangent now. So I think this is the important that you have to write as an important point. Now tangent to a circle, that is second topic. How tangent is made, that we want to see. In a previous section you have seen the tangent to a circle is a line that intersects the circle at one point, only one point. That is a definition of tangent. Tangent to a circle is a line that intersects the circle at only one point. To understand the exercise of tangent to a circle at a point, let us do the following activity. हम एक एक्टिविटी करेंगे, उसके अंदर if you will see properly, so different lines are there. If you will see, start from AB, line AB. So straight here by here, but we can say it is a line AB. So line AB, line A dash B dash, line A double dash B double dash. We give name as a R1, R2, R3, Q1, Q2, Q3. So A1, AB, that is we can say PQ1, A dash B dash. So A dash, here it is A dash B dash, that is PR1. So if you will see properly, P here, if you will see that again here, but these all are the second, because mostly all lines, but one line as we go, so lines are reducing. In various positions the wire intersect the circle wire at P and at another point Q or Q1, Q2 or Q2, etc. In one position you will see that it will be intersect the circle at the point P only. C A dash B dash of AB. AB का जो A dash B dash line है वो एक ही point पे touch करेगा. This show that tangent exists at only one point. Or we can see that આમ જોવું હોય તો આમ થતું જાય reduce. We can say reduce. Length છે reduce करती जाए. एक condition ये भी आवे. एक condition उसका ऐसा रहेगा कि वो touch होके जाएगा. So this is activity based. There is only one tangent at a point of circle. So if you will say that how many tangent we can pass through the circle, so infinite, because every point we make a tangent. At every point we make a tangent, At every point we can make a tangent. So every point we make a tangent. So infinite tangent can pass through the circle, touch the circle, but only one is, two pair is parallel. Let me see also this. So there is a only one, always remember, this is the remember point. There is only one tangent at a point of the circle. Each point, but we have to make a point, different point at here. So we can make. So while doing activity, you must observe that the position AB moves toward the position A dash B is to the common point, say Q1. As we go gradually, the near point, so common point R3 gradually comes nearer and nearer to P and ultimately coincide with P. That is important. Length उसका छोटा होता जाता है और वो एक ही point हो जाता है. So tangent to a circle is a special case of secant when two endpoints of its corresponding chord coincide. That is a definition of tangent. Again, it's important. So this is the third point. First paragraph already we have. Tangent to a circle is a special case of secant when two endpoints of its corresponding chord coincide. Now tangent is a word derived from. The word tangent comes from the Latin word tangere, which means to touch, and was introduced by Danish mathematician Thomas Finney in 1583. So we have cleared the concept related secant, tangent, chord and circle. Now how many tangents are parallel to each other? So if you will see here, only two. So these are the tangent to the circle parallel to the given secant PQ. So how many that? This also help you see that there cannot be more than two tangent parallel to the given secant. So if circle is there and if we want to make a parallel, then only two tangent is possible which is parallel to the secant, or we can say diameter. So diameter को parallel कितने tangent we can draw it? तो के maximum two tangent is parallel to the secant. So these two is parallel. If I will say here it is a diameter of a circle, here it is a diameter of a circle and we have to make a point. So always remember at most two lines, two tangents are parallel to the given circle. Now what we can say about the common point of a tangent and the circle is called point of contact. So if I will draw one tangent at here, so here it is called point of contact. Point of contact. The point A in the figure 10.1 and the tangent is said to be touch the circle at a common point. Now we go for the theorem 1, that is 10.1. So important theorem related the it, that is 10.1. So first of all we have write what is a theorem 10.1. Theorem 10.1. The tangent, that is given as a statement, the tangent at any point of a circle is perpendicular to the radius through the point of contact. That at any point of a circle is perpendicular to the radius through the point of contact. Now we have to prove this. So if you will see properly, proof. So before we started, what is given? So we have to write given. Always remember that when theorem is there, 4 marks or 3 marks theorem is there. In 4 marks or 3 marks theorem statement, given you have to write half marks. To prove, again half marks. Proof, again half marks. So given, to prove, proof and diagram, or we can say figure, to get half marks. So 2 marks you can easily got it. When theorem and proof statement, theorem 4 or 3 marks should be asked in exam. 4 or 3 marks theorem, you will get easily 2 marks. Half marks for the given, you have to write properly. To prove, you have to write properly. Proof, we have get more marks. But if you write properly, because given half marks, to prove half marks, figure half marks. So 1.5 marks already we have got out of 3 or 4 marks. Or other remaining 2.5 marks for proof. So now we have to prove today theorem 10.1. So what is given that we have to write? Given. What is given? We are given a circle. So a circle with center O and a tangent xy. What is given? A circle with tangent xy to the circle at a point P. What we have to prove? So what we have to prove? To prove OP is perpendicular. OP is perpendicular to xy. OP is perpendicular to xy. That we have to prove. So actually theorem is not too much large. It is small, not too much large. Again, theorem 10.1. Tangent at any point. So you will see that circle is there. Tangent at any point of a circle. Tangent at any point of a circle is perpendicular to the radius through the point of contact. So if you will see properly figure 10.5. Here one tangent. So what is given? A circle with center O. A circle with center O and a tangent xy and a tangent xy to the circle at point P. What we have to prove? OP is perpendicular to xy. So OP is perpendicular to xy. That we have to prove. So we start to take from here. Now proof. That is our proof. So mostly what happen, if we construct something, here we are taking a point. So we have to write for construct. What we have to construct? Take one point P. So take a point P on xy other than P and join OQ. See the figure, don't write 10.5. ऐसा लिखना नहीं चाहिए. Just we have to write to take a point Q on xy other than P and join OQ. The point Q must lie outside the circle. Question is why? We cannot write it. Note that if Q lies inside, then circle will become a secant and not a tangent to the circle. Here point Q must lie outside the circle because it is greater than radius. So OQ is greater than radius. That is why it is outside. Take a point P on xy other than P and join OQ. See the figure. So OQ is greater than R. If Q lies inside the circle, then xy will become the secant and not a tangent of a circle. If it is smaller than radius, OQ OQ is less than radius, then it is the secant of a circle. So it is not a tangent. Therefore, OQ is the longer than the radius and OP of the circle. Therefore, OQ is longer than the radius and OP of the circle. Therefore, OP greater than, see you, OQ is greater than OP. Since this happen for every point on the line XY except the point P. So OP is the shortest of all the distance of the point O to the point XY. So OP is perpendicular to XY. Theorem here is shown in theorem 1.7. So it is not necessary to write. So again I am explaining properly. Take a point Q outside it and join OQ. Now we have to say that OQ is greater than radius, so it is outside. If I will take OQ less than radius, then it is inside, then it is called secant. So only one possible, that is OQ greater than OP. Now P is a point. What happened every point to the line XY except the point P? You will see that point P is on XY. So OP is the shortest of all distance of the point O to the point XY. OP है वो shortest distance है XY के जितने भी point है उसके ऊपर से. So hence it is proved. So you have to write theorem 10.1. Now we go for the exercise 10.1. So I think we concentrate on here first. All other side. How many tangents can circle have? So infinite many. Tangent to a circle intersect at one point. Tangent to a circle intersect it in one point. A line intersect a circle into 2 points is called secant of a circle. Parallel, a circle have two parallel tangent at most. Two parallel tangent. Common point of a circle, common point of a tangent to a circle and the circle is called point of contact. Is called point of contact. Now question number 3. PQ is a point. So we have to draw one circle first. PQ at the tangent PQ at a point P of the circle. Point P of the circle of radius. So here it is 5. Meet a line through the center O at point Q. OQ is equal to 12. Then find the length of PQ. So we can apply the Pythagoras at here because it is a perpendicular. So by applying Pythagoras, OQ square is equal to OP square plus PQ square. So OQ, that is 12 square, is equal to 5 square plus PQ square. So PQ square is equal to 144 minus 25. That is 119. So PQ square 119. Therefore PQ is equal to under root 119. So here D option is given. So exercise 10.1 and theorem 10.1, that is important. You have to write it in proper way. So in your fair book you have to complete exercise 10.1 and you have to show your last chapter, that is chapter number 5, that you have to complete anyhow in your fair book because you have to put your marks related with the exam, internal marks.